this problem from group theory, and the problem is show that the set of all rotations p theta rotate xy to x dash y dash. This is the old coordinate and this is the new coordinate, where the formula of rotation is given by x dash, this is equal to x cos theta minus y sin theta, and y dash, this is equal to x sin theta plus y cos theta, forms a group with respect to multiplication. Okay, and to show these rotations forms a group with respect to multiplication or with respect to the composition of mapping, we have to prove 4 properties of group. Okay, now the first property of the group is closure property. This is the first property. To prove the rotation is closed or satisfy the closure property, we take 2 rotation, that is, one is t1 theta, this is xy to x dash y dash, and second one is t2 phi, this is x dash y dash to x double dash y double dash. Okay, we take 2 rotation, t1 and t2. Now the product of 2 rotation, that is t2 into t1 or t2 composition t1, this is the rotation, and this rotation transform the point xy to x double dash y double dash, because by t1 it is transformed from xy to x dash y dash, and by t2 it is from x dash y dash to x double dash y double dash. Okay, now here we write the formula of x double dash y double dash like this. This is x double dash, this is equal to x dash cos phi minus y dash sin phi, and y double dash, this is equal to x dash sin phi plus y dash cos phi. Okay, now we write the x dash and y dash, this and this. Here we get x double dash, this is equal to x cos theta minus y sin theta into cos phi minus, in place of y dash we put x sin theta plus y cos theta into sin phi is here. So we get, by taking common x from this term and this term, we get this is cos theta cos phi minus sin theta sin phi minus y into sin theta cos phi plus cos theta sin phi. So we get this is x cos of theta plus phi minus y sin of theta plus phi. Okay, we use 2 formula of this and this. Also y double dash, this is given by, we put the value of x dash and y dash from this and this, we get this is x cos theta minus y sin theta into sin phi plus the value of y dash is given by x sin theta plus y cos theta into cos phi. Okay, so we get similar manner x into sin theta plus phi plus y into cos theta plus phi. This is y double dash and this is x double dash, and from this formula and this formula we say that T2 into T1, this is also a rotation, and rotation by the angle theta plus phi. Here also theta plus phi. So we can write this is theta plus phi. Okay. So we say that the composition of two rotation by the angle theta and phi is also a rotation by the angle theta plus phi. So composition of two rotation is also a rotation. Okay. That is, if T1 and T2 belongs to the set G, let it be the set G, all rotation belongs to a set G, then T2 composition T1 belongs to G. Okay, so closure property hold. So closure law hold. This is the first property of group, right? And now the second property. Second property is associative. And for the case of associative property, we know that this is a rotation, and rotation means a function, right? And we know that the function is always associative. This is the general property of function. Okay, and since function is associative, so the rotation must be associative. Okay, and we here write that if T1, T2 and T3, T1, T2 and T3. Okay, and if it is the rotation of theta, and it is the rotation of phi, and it is the rotation of psi, and this is from xy to x dash y dash, and this is from x dash y dash to x double dash y double dash, and this is from x triple dash y triple dash, then we get that the composition of three rotation, that is T3, T2, T1, and this is T3, T3, T2, T1. Both are the rotation by the angle theta plus phi plus psi. Okay, so associative law hold. Okay, this is the second property of group. Now the third property. This is the property number 3. This is the identity property. Okay. If we put in place of phi, this is equal to 0 or 0 degree. Okay. Then it is clear that from this relation T2 composition T1, this is given by theta plus 0. Okay, and theta plus 0, this means T2 T1 of theta. Okay, and hence we say that T2 0, that is x dash, this is equal to x cos 0 minus y sin 0, this is x, and y dash, this is x sin 0 plus y cos 0, this is y. Okay, that is xy, this is equal to x dash y dash. This is the identity rotation. Or rotation by angle 0 degree. Okay, this is the identity rotation, and we name this rotation as TI0, and this is belongs to G. This is the identity law, or this is the identity property of this set. that is the set G. Okay, this is the third property. And the last property is, the property number 4 is inverse property. Okay, what is inverse property? Here it is clear that from this product, if we put theta plus phi, this is equal to 0, that is phi this is equal to minus theta. And if we put phi this is equal to minus theta, then we get from this relation we get x double dash, this is equal to x dash into cos minus theta, this is cos theta, minus y dash into sin minus theta, this is plus y dash sin theta, and for y double dash this is x dash into sin minus phi, this is minus sin theta, plus y dash cos theta. Okay, and this rotation is T inverse minus theta. Okay, and this is T2 minus theta, and this is given by T1 theta inverse. Okay, and T2 minus theta is belongs to here, T2 minus theta must be belongs to G, and this is the inverse of T1 theta. Okay, so we get the inverse of all rotation. So all the property of group, that is closure, associative, identity and inverse, hold for this rotation. So we say that this is a group under composition of mapping or under multiplication. Okay, this is from your university previous year paper. Thank you for watching.